All right, so first up for day 2 is going to be residual plots. Definition is it's going to be a scatter plot of residuals against the explanatory variable. These help us assess how well a regression line fits our data. Yesterday we were talking about the scatter plots of used Honda CRVs, the number of miles driven compared to the predicted price. So we looked at a scatter plot. Today what we're going to do is we're going to turn that scatter plot into a residual plot. So if you take a look here, both of these are in your notes. The scatter plot here is going to be on the left. The residual plot is going to be on the right. Okay. Things that you need to know is that with a normal scatter plot, you're going to plot the explanatory against the response. Explanatory helps to explain the response. So remember, in our Honda CRV question, we're talking about the amount of miles driven in the thousands compared to the price. So the miles driven seem to be lowering the price, correct? Over here on the right is a residual plot, and it compares the number of miles driven to how off you are on each of those calculations. So we're going to take a look at that. What we're going to do now is we're going to do some calculator stuff. So do me a favor, go ahead and take out your calculator, and hopefully you guys have some of the data already kind of saved in there. So I'm going to go to my calculator on the board, stat, edit. Do you guys have this data somewhat still in your calculator? So go check to see if you still have this in there. If you do, great. If you don't, do me a favor, take a minute, type it in. All right, if you don't have it, take a minute, type it in. All right, so what we're going to do now is we're going to talk about how to calculate these residuals in your calculator, okay? So do you guys see how I'm highlighted up here at L3? I want you to press enter and notice that you have a little blinker down at the bottom for L3. Do you guys see that? All right, remember, to calculate a residual, first you need to take the observed value and subtract the predicted value, right, or the expected value. In L2, we have our observed values, correct? But we are lacking that expected or that predicted value, right? So how do I find these predicted values? Plug the explanatory or the x values, like this 22, this 29, and 35, into the least squares regression line. Do you guys remember the least squares regression line from yesterday? Go ahead and flip through your notes, see if you can find it. So find your least squares regression line from yesterday. You guys find it? What do you got? It's what? 18,773.28 plus what? Or actually, it's minus, right? Oh, I messed up. I messed up bad. There we go. So, what was it? 18,773.28 minus 86.18 times what? Well, times all the x's, correct? I wish there was a quick way we could get all the x's.
L1.
Oh, it's L1. So notice I can press second 1, and notice that's L1, right? You guys see that? And if I press enter, boom. Isn't that fancy? That's like fancy stuff.
Think about you in 2005. Did you do that in your exam?
No, I did not. I did
I
not.
think you did it all by hand.
I didn't have to do that. Well, I can't spoil the problem. Rogers, you're helping me spoil the problem here. All right. We'll have to find out tomorrow what the problem is here. Okay, so now I have the observed here, in this, here's the observed, and here are the expected, correct? So how do I find the residual? You subtract those. So how do I do that? L2 minus L3. You guys see how I'm going to do list 2 minus list 3? So it's basically each of these left column values minus their, I guess, corresponding right column values, and that's going to give me the residual values. Okay, let's see if you got that. Do I need to re-explain any of the L1, L2, L3 magic I did? Question, JT.
L3.
Okay, so L3, did you go up here and then press enter when you highlighted? So now you type in the least squares regression line. So to type that in, that's 18,773 So you have to press enter to be able to type, minus the 86.18. And that's what we did in class yesterday in terms of calculating. We calculated the least squares regression line yesterday. And then we're going to do second one, and then that's going to give us all of those predicted values. Okay, take your time. And then we're going to press enter, and then it does all that. Just remember, like, if you want to access the list up here, you have to press enter and then type to do that. All right, second y equals next is what you need to hit. So second y equals. Here, you guys should notice this is a familiar menu. Okay. Here we've gone to graph box plots, histograms, etc. Guess what this can also do? Stat plots or scatter plots, right? So do you guys see the first one here is a scatter plot? All right. Now, notice that if I keep L1, L2 there, right? And I hit zoom 9, you're going to get the scatter plot from yesterday's notes. You can see this on the front page of your notes. All right, so you have the front page of your notes there. Do I want a scatter plot right now? No, what do I want? Residual plot. So do you guys see down here at Y list, I need to change L2 to L4. Because 3 is where the predicted values are, 4 are where the residuals are, right? So once I change this to L4 and I hit zoom 9, notice that's going to bring up this residual plot. All right. So notice that plot should match the one that's on your paper. Do you guys see that? What we're now going to talk about is this a good residual plot? Does this tell us information? How do I interpret a residual plot? And these are the questions we're now going to answer. Okay. If you do a linear regression test for your final project, you will need to know how to do this. Notice in the little box on your notes there, you have a little step-by-step guideline. So just follow the steps there and you'll be able to create your own residual plot over and over and over. Does that make sense? Okay, so what we're now going to focus on is the major piece for today, examining. All right, so I need you guys to be with me on this. If a regression line captures the overall pattern of the data, then there is no pattern or should be no pattern within the residual plot. Okay. Basically, in blue and box in green is the Cliff Notes version. All right. If the residual, if the least squares regression line is a good fit for the data, there should be no pattern within your residual plot. It should look like confetti. No pattern, no rhyme or reason. I have a question. Is that what you see in your residual plot? Therefore, you can say that your least squares regression line is a good fit for the data. Another way you could tell is looking at the correlation. You guys remember the correlation from yesterday? That's previously in your notes. You can look back and forth in your notes. Anyone find the correlation value from yesterday? Answer is yes. I can look back at my notes. Negative 0.874. And what do we call that? What do we describe the correlation being yesterday? A strong negative linear association, right? Notice that even supports this scattered random residual plot that we have, right? Good. Residuals should be small in size, and the reason they should be small in size is because residuals are basically what? Error. Do we want a lot of error? No. So large residuals mean we have more error within our regression model, and that, my friends, is bad. All right? Okay, so that, my friends, is bad. All right, one of the units here, which is going to be the next little piece of notes for today, is going to be talking about the S value, what we call the standard error of the residuals, or the standard deviation of the residuals. What that's going to give you is the average size of a residual, and we're going to talk about interpreting that in context. So that's going to be a numeric, like a numerical summary that goes with, hey, how much error does your regression line have? And that's what we're going to talk about. Cool? Yes? Excellent. All right. So if we use an LSRL, least squares regression line to predict values, this formula here gives us how we can calculate the standard error of the residuals. I want you just to take a look at that. Now, you don't have to write that down. You have to write that down. It's already printed for you. It's already printed. Oh, I know. Such a nice guy. What does this look similar to? A lot of you guys think chi-square. It's actually more similar to something else we've done. Observation minus the mean squared divided by n minus 1, take the square root. It's basically standard deviation. This should very much appear like standard deviation. And it is, except for dividing by n minus 1, you divide by n minus 2. Anyone want to take a guess why I divide by n minus 2 instead of n minus 1? Say that louder, Miranda. 2 variables. Nice job, Miranda. Now, here's the thing about this formula. Is it nice to know how it is, how to find it by hand? Sure. However, we have a calculator for that. We're going to use technology to do most of the grunt calculations for us. What we do need to know is what it means. What does this S value mean? So it's not super important to know how to calculate it because your calculator can do that. However, it is far more important to know how to do it. It's statistically superior to know how to interpret versus how to calculate. Right, Calvin? Statistically superior. All right, to find S, what you're going to do is you're just going to basically do 1 var stats of L4. Because of how we usually did standard deviation is just stat calc 1 var stats, but of L1. Here, when we do stat calc L4 for 1 var stats, actually I'm going to go back to my calculator real fast. Remember that we are going to change this, and L4 are where my residuals live, correct? So this is about my residuals. Notice here that the average, the mean of the residuals, what does it average to? 0. Basically 0. Roughly 0. The S value that we're looking for is the sample standard deviation. You guys see this? That is going to be our value. That's the important value for today in terms of the standard deviation of the residuals. So we're looking at S. Now we found it. We just got to now describe what it is. Again, it's the average size of the residual. So basically, every time that you use your least squares regression line, you're probably going to have some error unless it's a perfect fit. Most least squares regression lines are not. So there's going to be an average amount of error over time. That is what S is. So basically, when we interpret it, we want to talk about how much we expect to vary in our predictions using our least squares regression line. So this was for our Honda CRV examples, right? Mm-hmm. Yeah. So if the standard deviation value here, again, is this 921.79, what does that mean? What does it mean? It's the average amount you're off and doing what? Predicting. What are we predicting? The cost of the car, the predicted price, right? So here, we're going to interpret it like this. We will vary by $921.79 in our prediction of the cost of used Honda CRVs using the number of miles driven. All right? So we are going to vary by $921.79 in our predictions of the cost of used Honda CRVs using the number of miles driven. And that's thousands of miles. So that means every time that you use the number of thousands of miles driven, you're an average of $921 off. It's not great. I agree. But just because that's the average doesn't mean it's like every single one. So sometimes it's going to be smaller, sometimes it's going to be bigger, but the average one is going to be that.
Can I show you computer card? Thank you.
The whole card?
Whole card. Okay.
The whole card. Say hi to YouTube.
Oh, hi YouTube.
All right, you guys have all those? Well, less giggling, more writing, Taylor. Okay, you're doing the exact opposite. You're now even giggling harder. This is what I deal with on a daily basis. All right. S. S is, again, the standard deviation of your residuals. It gives you the average amount you're off when using your least squares regression line to predict. Sometimes it could be more, sometimes less, but that's the average generally. Coefficient of determination. It's determined to go into your brain. Yes. Okay. This value is what we call R squared. Last year on the AP exam, this was part B of the question I answered, or I graded, excuse me. Part A was, can you interpret the y-intercept in context? Part B, interpret R squared in context. You remember that, Malia? With the interpret R squared, you remember doing that? It's okay to say no. Kind of. This is the percent of variation in y that can be explained by x. The variation in y that can be explained by x. So it's going to be a number. It's related to its cousin, r. This is r squared. Its cousin is r. How do you go from r to r squared? You square r. You see that? Isn't that fancy? All right, trick question. How do you go from r squared to r? Yeah. That's how they're related. All right, most times you're going to have this value either given to you or you can calculate it very quickly. We just made the note here that the square root of r squared is going to be plus or minus r. Now the tricky question is, when is that value going to be positive versus negative? When is that value going to be positive versus negative? Whenever the line is positive. Whenever the line is positive or negative. So basically it's dependent on the direction, which is the slope. So if the slope is positive, r is positive. If the slope is negative, r is negative. It makes a lot of sense. Regardless if r is positive or negative, r squared will always be positive. When you square something that's negative, it's positive. When you square a positive, it's still positive. So I'm pretty positive that r squared is always positive. You with me? All right, so from our other example, remember from 1D of your notes, you guys have your notes, right? The correlation is negative 0.874. So how do I find r squared? You square it. So anybody want to know what negative 0.874 squared is? Can someone tell me that? Anyone want to know and tell me?
0.7639.
0.7639, roughly 0.76, correct? All right, so what this value is, and we're going to probably do an activity a little bit later this week, early next week, to kind of really understand what r squared is talking about, more as a review for the AP exam and also a review for linear stuff. Okay, today I'm just kind of giving you what it is, and then we're going to delve later into it. It's basically the amount of variation that can be explained. It's the amount of variability that we can account for. So notice when you explain it or in words, it says 76% of the variation in the predicted or in the prices of cars, or in the cost of Honda CRVs, can be explained by the thousands of miles driven, or the number of miles driven. Right? So that means we can account for 76% of that variation, which means we cannot account for 24. That's some other reason that we have that variation. But we know about 76% of the variation is going to be accounted for by the number of miles driven and the variation of the prices or the cost. So verbatim, it should, and I'm not even looking at the screen. You guys see I'm not even looking at the screen. It's 76% of the variation in the prices upon the CRVs can be explained by or can be accounted for by the number of miles driven. That's roughly that.
At least that.
Really? Fancy. It's like I know how to interpret R squared or something.
It's like you've been doing this for
At years. That's my first one. Anywho, very important. Go ahead in your notes. Do me a favor. Start this. Literally on the AP exam last year, free response, number 1. Had to know how to interpret R squared. So do me a favor. Exams a week from tomorrow. Should you know how to interpret R squared before it? Yeah, I would. I would know how to interpret slope and interpret y-intercept. Least likely is probably going to be S, but I've seen it before. The major 3 things are R squared, slope, correlation, and y-intercept. After this example, do you even know what one looks like? We'll Google it. All right. Now the AP exam loves Minitab and these JMP output, like loves them, like they're everywhere. So you need to know how to read one. So the space in your notes below is so you can make some notes here about where to find what values, right? Minitab is going to be probably what you're going to see more often. So you need to know where things are. Generally, you guys see this COF column, the coefficient column. This is going to be where you're going to find your least squares regression. This is where your LSRL lies. That's where it is. Top number with constant is going to be the y-intercept. The NEA underscore change is going to be the slope. All right, and these are already notated for you, but if you want to make some certain notes there. Standard deviation of residuals, that's S. Notice where that's located. So they say S equals. You just have to know what it is. It's the standard error of your residuals. R squared is right smack dab in the middle. Do you guys see R squared adjusted? No, you don't. You really don't. Right? Do you guys see R squared adjusted? No, it's not on there. Like this one, not actually on there. Okay, when we do confidence intervals and hypothesis testing later this week, we're going to be using these. This is for CIs and hypo tests. Do you guys see these T statistics? These are going to be the T statistic, like the test statistic. Guess what this is going to be? P-value. Hey, p-value 0. Compare that to 0.01, 0.05, 0.10. Reject HO in favor of something, right? You guys just don't know what we're comparing it to and what we're looking at, right?
Yep.
But you will if you're here tomorrow and or Friday. You guys good with that? Okay, so you just need to know the basic outline here. Okay. We will also use this SE coefficient column when we talk about inference procedures with this. So you need to know Minitab pretty well. Super important. Notice that JMP is pretty much similar to it. If you know how to read one, you can probably read the other. Okay. All right, we have an example. It says a college teacher asked a random sample of 10 of the 250 students in her intro stat class to record the total amount of time they spent studying for a particular test, and then combine these times with the students' test scores on the test. She then performed a regression analysis on the data below as the numerical output, not the graphical, just the numerical output, from her computer software. All right, so I made up some questions to kind of practice with you guys. So this is a scenario. Can you write the least squares regression line for this scenario? Okay, where am I looking to find out where this least squares regression line is? Under the co-if button, or not button, column, I guess. All right, do you guys see where it says constant? This is generally going to be the y-intercept piece, and the other one's going to be the slope. So the first thing I'm going to ask you is, all right, what are we attempting to predict? Time? Scores? Are we predicting time or scores? Scores. Scores? Scores. S scores. Test scores. You are predicting test scores based off the amount of time you're studying. All right, so let's do this. What's 62.1? That's going to be our y-intercept plus 12 times number of hours studying, spent studying. I guess I should say spent studying. All right, and that's it. I don't know why I have a double underline there. Here, I'm going to try to make it symmetric. Yes, no?
Yeah.
Cool. Next. Standard deviation of the residuals. What is that? And can you interpret it in context? Can you find it? What is it? S. What's S? 7.737. Correct? What does this thing mean? It's the average value of a residual, right? And residual, again, is what? Error. It's how far you're off in your predictions. So we will vary by not hours. Because remember, what are we predicting? Points. When using our least squares regression line to predict test scores based off of number of hours spent studying.
Students that are in here see this stuff and are like, yeah, I'm not taking stats.
Maybe.
I would.
I think the calculus kids say that.
That looks like a lot.
Like the n+1 factorials, or are you talking about the inverse procedures?
procedures.
Oh, we're going to add them tomorrow, Taylor. You're going to be here. Who's going to add them to the board?
What are you going to do, Taylor? Taking my AP stuff. Oh.
You could come in the morning, second period.
Yeah.
Right. We can't sit there. Chandler sits there.
We'll see.
Push it out and see. Thing. All right, next. What is the correlation coefficient? And what does that tell you about the linear relationship between the amount of time students spent studying and student test scores? All right, so I have a question. What is the correlation coefficient, friends? That is R. Very good. So how can I find R? Is it in the chart? No, but I can find something it's related to. Its cousin. R squared. Do you guys see R squared adjusted? Nope. You don't, right? It's a trick question. Like you see that and you're like, no, what R squared adjusted, right? As you mark it out on your paper. The reason I had you mark it out on your paper is because I don't know how it's been adjusted. Anything that's been adjusted, we don't really trust. So we're just going to use the regular R squared. Does that sound good? That sounds like a plan, right? Okay. R squared is equal to 69.3%, which is going to be, as a decimal, 0.693. Agreed? So how are you going to find its cousin? Square root. Hello, cousin. Positive or negative? How do you know if it's both versus one versus the other? You need to look at the slope. What's the sign of the slope? So this is going to be positive point what? 832. Okay, so I have a question. How are we going to assess the linear relationship between these two variables, given that the correlation is 0.832? What do we use to help us do that? DOFs. You guys remember DOFs? D stands for? O. F. Form. S. Strength. If I don't have a graph, probably don't talk about outliers, correct? Can we talk about D? Direction? Positive. Because slope is positive. F? Form. Linear, because correlation talks about something that's linear. And given that it's pretty high, 0.832, it's a pretty strong one. If you're worried, you can use moderately. That's even fine. Yeah. I mean, it doesn't sound as cool as moderately strong, but kind of strong is all right.
I refuse to dig up some dirt on my essays today for AP English. Wrote what?
Now I'm intrigued to ask why.
It's about this one of the essays that goes wrong. It was about this.
Oh, it gets released in 2 days.
Oh no, it was the no, it was the
Guys, it'll be up in 2 days. It's fine.
like dirt on the people.
Oh, that kind of dirt.
Yeah, like the borders.
Oh, you're talking about literally digging up dirt.
No, I was
Oh, you're not. Now I'm really confused.
She had a boarding pass, and she was like, was it the poem or?
No.
Oh, okay. And she was like, yeah, and she was like stalking them. Not you, these things.
No one watches my YouTube channel. Not yet.
Subscribers.
Like 5 years from now, they're gonna go back and cancel.
Yeah, your scores deleted.
Well, they don't know who you are. Unless you want me to give him your name. You want me to give him your name?
We're good.
You're good? Okay, anyways. There is a what?
Positive, linear,
Moderately strong.
strong, linear.
That's how I like to go. I like to do direction, strength, form. There is a positive, moderately strong, linear relationship or association, either or, between the amount, time, students spend studying and student test scores. All right, you guys good? All right, let's finish out the last part, and then we're done for today. We'll explain the other stuff a little bit later. Is that cool? Form, what is the coefficient of determination? And interpret this value in context. What is the coefficient of determination and interpret this value in context? Which one's the coefficient of determination? That is R squared. R squared. Generally on the AP exam, they're going to tell you to interpret r squared. They're going to literally say, interpret the value of r squared. Or what is r squared? Interpret this value in context. So you have to find it, then interpret it. So what is r squared? R squared is equal to 69.3%, or you could say 0.693, correct? All right, remember that this is the one where we talk about the variability being accounted for. This is when we can account for the variations in things, right? So 69.3% of the variation in test scores can be explained by the amount of time spent studying. Good? All right, cool. Please make a note of your homework assignment on page 191, 193. It's 59, 60, 62, 64, and then 71 through 78 all. 71 through 78 all are multiple choice over linear regression. So be sure to check the odd answers in the back of the book. I'll have the even answers available for you to check during class tomorrow. Also, you have AP multiple choice 21 through 32 tomorrow. And then tomorrow night for homework, you will do the last 10, and then we'll take the quiz over it on Friday. You guys good with that?
Yeah.
Also, as a reminder, you're going to, or as an announcement, you're going to take a Chapter 3 quiz over the weekend. It'll be a take-home quiz this weekend, in addition to your assignment for linear t-tests. Linear t-test is not going to be a lot of stuff, so you're going to have a Chapter 3 quiz, so everything that we've done in class. We have to do a little bit of something tomorrow. I'm going to explain a concept to you, not too difficult. And then anything after that, the 12 stuff, because we're going to do 12.1 day 1 tomorrow, final day of notes on Friday, 12.1 day 2, and we are done with content, my friends. All right. Questions, comments, concerns? Anything for YouTube?
Please like and subscribe.
Please like and subscribe.